Hello there. Welcome to the solutions video for homework 2.4b, page 131. So I was able to get the first five on the board here. We'll talk through them. So number 43, y equals cosine of 3x. I went ahead and put the parentheses around the angle. The outer functions are going to be in blue, the inner functions in red, and if it's a three-layer onion, the most inner function will be in green, but this one only has two layers. Derivative of cosine 3x would be minus sine 3x, and then the derivative of the angle 3x there would just be 3. So let's bring that negative and that 3 out front and be negative 3 sine 3x. All right, 45, g of x is 3 tangent 4x. So tangent 4x is the outer function, 4x is the inner. Derivative of tangent is secant squared, so it's going to be 3 times secant squared, 4x, times the derivative of 4x, which is 4. 4 times 3 is 12. We'll bring that out front, and there's the answer. All right, 47, f of theta is 1/4 sine squared 2 theta. So this is going to be a three-layer onion because we've got the whole thing squared, and then we also have a number in front of theta. So let's rewrite this as 1/4 sine 2 theta. I put the 2 theta in parentheses, and then this 2 here means the entire sine of that angle is squared. So the outer function is the whole thing. Then the intermediate function would be sine 2 theta. And then the angle is the innermost function in green. So the derivative is going to be, bring that 2 out front, multiply by 1/4, and you'll get 1/2, times sine 2 theta, and we drop that to the first power. The derivative of sine 2 theta is cosine 2 theta, and then the derivative of 2 theta is 2. So cleaning all that up, 2 times 1/2 would just give you 1, and you're just left with sine 2 theta, cosine 2 theta. And if you prefer at the end to take the parentheses back out, that's fine. I'm going to leave them in. All right, we have y, number 49, y equals the square root of x plus 1/4 sine 2x all squared. So this time also a three-layer onion here, because not only is there a 2 in front of the x, there's the angle itself is squared. Now that's different than 47 where the entire sine is squared. Only the angle is squared here. So the outermost function is sine 2x squared. The intermediate function would be 2x squared. And then the angle 2x is our innermost function. So the derivative of root x is 1/2 x to the minus 1/2. And then you would have cosine 2x squared is our derivative of the blue, 1/4 in front. And then 2 times 2x, and then to the first power, that 2x squared, that red function, the derivative of 4x. And just inside the parentheses, that 2x, the derivative would be 2. So I've got 2 times 4x times 1/4. That leaves 2x, because the 4 and the 1/4 cancel. Cosine 2x squared. And I went ahead and made that x to the negative 1/2 into, brought it downstairs and made it 1/2 root x. Okay, we're back to a two-layer onion on number 51, sine of cosine of x. So luckily it's not cosine of 2x or cosine of 3x, anything like that. That would make it a three-layer onion. It's just cosine x. So it's going to be the outer function blue, the inner function red. The derivative of sine cosine x would be cosine cosine x. And then the derivative of cosine x is negative sine x. And just cleaning it up, I'm going to bring that negative sine x out front, so you don't confuse it with the angle there. So we have negative sine x times cosine of cosine x. All right, that does it for most of the trig. I think in the rest of the homework, one of them also is trig. So pause the video if you need to. Okay, let's look at 53. So the instructions on 53, we want to evaluate the derivative. We have s of t equal to the square root. In fact, I think it's the square root. Let's go ahead and write it to the 1/2 power. So we have t squared plus 2t plus 8 to the 1/2 power. So s prime of t, this is a chain rule, bring the 1/2 out front, t squared plus 2t plus 8 to the minus 1/2 power times the derivative of the block, that inner function within the parentheses. So that would be times 2t plus 2. All right, let's clean that up, make it easier to plug in. We would have 2t plus 2 on top, and on the bottom, 2 times the square root of t squared plus 2t plus 8. Now, if you want to factor a 2 out of the top and you have a 2 on the bottom and cancel, that might make it easier to plug it in. So s prime, we're plugging in the x value, which is 2. That's going to be 2 times 2 plus 2 over 2 times the square root of 2 squared plus 2 times 2 plus 8. All right, 4 plus that would be 6. And then 2 times the square root of 4 plus 4 plus 8. So square root of 16. So that's going to be 6 over 2 times 4. So 6 over 8, which would reduce to 3/4. And let me check. Yep, that is the answer. Okay, let's see if we can squeeze number 57 in. I think we can. So I have f of t is equal to 3t plus 2 over t minus 1. This is not really a chain rule, just a good old quotient rule. And we're going to be plugging in, going to get to plug in 0. So the point 0, negative 2. So I like that. So f prime of t, bottom, t minus 1, times the derivative of the top, which is 3, minus the top, 3t plus 2, times the derivative of the bottom, which is just 1, all over t minus 1, all squared. So plugging it as 0, that's going to be negative 1 times 3 minus 0 plus 2, so just minus 2, over negative 1 all squared. So it's going to be negative 3 minus 2, which is negative 5 over 1. So I'm hoping that the answer is negative 5. It is. All right, brilliant. Okay, we're moving along pretty good here. Got to do the tangent line equation for the next two, so number 61. So these are really good review problems for the test. We've got f of x, and I'm going to go ahead and write this as 3x squared minus 2 to the 1/2 power, and we're at the point 3,5. Right, so f prime of x is equal to 1/2 times 3x squared minus 2 to the minus 1/2, and then don't forget the block, so times 6x, the derivative of the block. That's going to be, if I clean this up a little bit, 6 over 2 would be 3x on top over the square root of 3x squared minus 2. So our slope, I'm going to plug in 3, right? 3 times 3 over the square root of 3. 3 squared would be 3 times 9 minus 2. That's going to be 9 over the square root of 25. Okay, so I'm getting 9/5 there. That's our slope. So we have y minus 5 is equal to 9/5 times x minus 3. You don't need to clean that up anymore. That's perfect. Okay, 63. We've got f of x equals sine 2x. Okay, so we've got a little chain rule here. F prime of x is equal to cosine 2x times 2. So f prime of our point of interest is pi 0. So f prime of pi would give us the slope. So that's cosine of 2 pi times 2. The cosine of 2 pi is 1. So 2 is equal to our slope. So I've got y minus 0 is equal to 2 times x minus pi. So, I mean, you don't have to put the 0 in, but you can just leave it like that, and that's fine with me. So y equals 2 times x minus pi is perfectly acceptable answer for me. The book might put it in standard form. Who knows? But this is perfectly fine. Even this is perfectly fine. Okay, 2 more to go. Number 75. We have f is equal to 132,400 over 331 plus or minus v. So part A says we're going to use the minus 3 part. We want to find the rate of change at 30 meters a second. So f prime, so this time we're using minus v. So f is 132,400 over 331 minus v. So f prime is equal to, okay, the bottom, 331 minus v times the derivative of the top. That's just a number, so 0. Minus the top, 132,400, times the derivative of 331 minus v. That's just going to be negative 1. All over 331 minus v, the bottom squared. So negative makes a positive. So f prime of v is going to be positive 132,400 over 331 minus v, all squared. We want to know what is it at 30, so that's 132,400 over 331 minus 30, so that's 301, right, all squared. And if your calculator doesn't betray you, 1.46, and it would be hertz per second. So that's the change in the frequency as it's approaching. So with the Doppler effect, it would be 1.46 hertz per second. The pitch is increasing by that much. And then B, almost the same, except this time F is 132,400 over 331 plus V. So F prime is going to be 331 plus V, the bottom, times the derivative of the top, which is 0, minus the top, derivative of the bottom, which is just 1. So our answer is just going to be negative because the fire truck's going away, and with the Doppler effect, the pitch would get lower, over 331 plus v all squared. So f prime of 30 would be negative 132,400 over 331 plus 30 all squared. And that is negative 1.02 hertz per second. So every second the frequency is going down by 1.02 hertz. So that means the pitch of the sound is also going down. Okay, that's Doppler effect. If you're the student that I'm have in 2024, we didn't get there in physics, all right, to the Doppler effect, but it is in the book. Okay, last problem, number 77. This one doesn't take up quite so much room. So we have a pendulum swing. That's also in physics that we didn't cover. Theta is equal to 0.2 cosine, and I'm going to write it like this, 8t. So part A is the first part, determine the maximum angular displacement. All right, and I gave you quite a hint on this, that the maximum that the cosine of any angle can be is 1. So the maximum angular displacement would be 0.2 times 1, which is 0.2 radians. Now part B, we're actually going to find the derivative for rate of change. So theta prime, so it's going to be 0.2, and the outer function is cosine 8t, so times negative sine 8t times the derivative of the inner function, which is 8t, so that derivative would be 8. So it's going to be minus 1.6, 8 times 0.2, minus 1.6 sine 8t. All right, the question is the maximum, the rate of change when t equals 3 seconds. So that's going to be theta prime of 3 is going to be negative 1.6 times the sine of 8 times 3 is 24. Calculator in radians, and that'll give you 1.45 radians per second. Okay, that does it for this assignment, and I will talk to you on the next assignment, which is the first part of the test review.